right. Yes. Welcome. Hello, guys, gals. Appreciate you hitting that play button. Let's go. Turning it up just for you. Yes, I love it. You guys are all awesome, every single one of you beautiful, intelligent people. Thank you for showing up. Thank you for showing up and learning and growing. You guys, every single one of you. 120 and higher IQ club. Let's go! Even if you're not there yet, we're going to get you there. Again, I appreciate y'all for the support and viewing the content. It truly is awesome. Quickly, even if you're not there yet, I just want to check the channel, make sure we're good. And it sounds like we are. Turn it up. Usual mod stuff. I got to make sure we're good. All right, welcome, guys. Parents, this is for you, homeschooling your children, your child's. Listen to your parents. They're awesome, okay? They're awesome. All right. So I'd like you guys to get your homework done and study and that and learn and grow, right? Look at it as you're helping yourself grow and learn and yeah, it's just all positive good stuff. Okay, guys? Just love it, because math is fun. It's good for the brain too. You're working it, you're thinking, right? All right, 120 and higher IQ club. Let's go. Those of you students that are probably in public school or whatever, maybe you're on YouTube looking for additional help and support. Here to help you guys and gals as well. You're totally 100% welcome to be here as well. Welcome. Appreciate you so much. Again, if you guys need any additional help, support, mathematical advice, support, if there's a particular area or subject in mathematics you'd like me to do, just let me know down below in comments. I'll turn it up for you and do a series just for you if it's required. Either way, I'll make sure. I love mathematics. This is fun for me, and I think it's great to do, especially when you're older. I'm just doing this because it's just great for the mind. All in all, it really is. Okay, it's not filled with garbage and toxicity and drama and useless, silly information. This is knowledge. Love it. Okay, enough of that, but let's get to it. Let's get going. Flick the old switch in the brain molecules and say, hey, it's time to learn. It is time to learn. Let's have some coffee and then we're gonna get going. Yes. Okay, hopefully the music isn't too loud. I think we're good. All right, so I left you guys and gals with this to kind of work out for fun, just for some practice. We're gonna do some more. This section seems to have quite a bit, so I'm gonna be trying to just push through it. Okay, guys? Let's continue. So, all right, turn it up. Left side equals right side. Make everything linear. Left side or left-hand side equals right-hand side, if you will. That's what we're doing. In order to do that, we must cross multiply. Okay. What I like to do, again, I like to have my variable on the left-hand side. So therefore, I'm going to go 7 times W equals right hand side 3 times 35. I can put this in brackets, that's fine. Close bracket. Now we're going to do the long multiplication here. I'm thinking it's 105. Let's see, let's find out. 3 times 5 is 15. 9, 10. Look at me. Look at me. You know how I did that? I know 35 and 35 is 70. Right? That's how I did it. So I know 30, it's 30 more to 100, right? So there's that extra 5, right? 105. That's mental math, guys and gals. So 105. So we have 7W equals 105. Pushing and grinding here for you guys. I love it. So if you've been following the series, hopefully you have been. If you haven't, you're kind of missing out on the little tips and tricks that I give. I recommend you kind of start from the beginning of the series in case you missed anything. I don't recommend just jumping into the middle of all this. So that's what I recommend. All right, follow the series, guys. Putting in the time for you. Okay, so let's isolate W, and we get 105 divided by 7. Now, how many times does 7 go into 105? I don't know, to be honest. I know 10 times 7 is 70. Okay, so if I added another 2 more, let's say 12, that puts me at 14. Carry the 1, that's 84. Let's do another one. 13 and 7, that's 21. Carry the 2, 7, that's 91. And we're going up by 7, so it looks like I could go 1 more. That's 14 and 7 is 28. 2, 7, 98. That's the closest I can get. Or can I go 1 more? 2. Oh, look at me. 15 times. There we go. I think that's what it works out to. 7 and that's 3. That's 10. Look at that. There we go. That's how you figure it out. Kind of have to work the problem, guys. Work the problem. So that was 15. Okay? That's the meat off the bone, so I can show the work. 7. Oops, let's go like this. Yeah, 7 is the magic number. And 15. 7 again, and 1, and we're left with 15 over 1, which obviously equals 15. There we go. Let's drop the yays. Now, something I'd like to do is, I kind of did the long work, guys, and I should have reminded myself that was a little bit of extra work doing that. So here's what I recommend. Okay, don't do the multiplication here yet. So watch this. So go like this. I should have did that first. This is what I always. My advice for you guys is to factor before you multiply. Okay, so check this out. 7. Okay, so we're going to break the 35. We're going to just leave the 3 by itself, hanging out. We're going to work with the 35 and the 7. Okay, Watch this. So don't multiply this yet. So we're going to break the 35 into parts. We know that 7 times 5 is 35, and we know 7 times 1 is 7, right? So 7 is our magic number. I'm going to go 5, right? 7 times 5 is 35, that's here. 3 is just hanging out, waiting its turn. Okay. I ran out of room, otherwise I would space it a little bit better. And then we know 7 times 1 gives us 7. Right? So there we go. There's our factoring. So I immediately factored right now. We took that 7 right out of there. So what we're left with is 3 times 5 all over 1. And by Jove, isn't that so much easier? We didn't have to try to figure out the largest number, right? Because we got our factoring done early. Okay? That's the tip. I'm going to try to remind myself to do that. It's kind of a step I forgot. Well, I didn't forget about it. I just kind of, temporarily was forgetful about that step. Again, I recommend if you can factor and reduce before you multiply, you're going to just save yourself time and stress at the end. You still have to reduce the problem at the end, right? But the thing is, you're going to end up having to figure out a larger number. That's okay. All right, let's do another one here. So we have 10 over 12 equals 15 over x. Okay, so here's my tip. Okay, the tip is never reduce like this when we have an equal sign in between. Okay, something I kind of slipped on in memory, but you can't do that. Okay, just to let you know, you cannot do that. The only time you can factor and reduce is if it's in fraction form. Okay, that's the only time. So as a matter of fact, I'm going to do that now. I'm going to take that 10 over 12 and I'm going to reduce that. So our common number is going to be 2. So I'm going to pull 2 out of both numbers. 2 times 5 is 10. And 2 times 6 is 12, right? So cancel the 2's. We're left with 5 over 6, right? I've already kind of reduced ahead of time here to save a little bit extra work maybe. We'll see. I should have erased all that first. Okay, 5, 6. Just want to clean it up here. So I showed you the work. You can see what I did. We just reduce this fraction. I think it's going to work. I want to find out. I like testing and kind of pushing my boundaries here and see what I could do to save some extra time at the end here. Okay, so we're going to still cross multiply. We'll see. We'll see how this works out. All right, cross multiply. We have 5x equals 6 times 15. Okay, x equals 6 times 15 all over 5. You guys should know the steps already. I'm kind of skipping all that extra work. You should know what I'm doing. Okay, again, so here we are. We have a fraction situation, right? So we can reduce. It's still a fraction, guys, even though we have two numbers in our numerator. So I'm going to reduce this, okay? So x is going to be equal. The 6 is just going to hang out for now. I'm going to break 15 into two parts. 5 times 3 and 5 times 1. 5's cancel. We're left with 6 times 3 all over 1. X equals 18. That's what I get, guys. And I'm gonna have to call that a big yays. Big yays. So it looks like, as a matter of fact, we can actually do that. We can actually reduce right at the beginning. And that's what I did, guys. I took that and turned it into that. Again, you're going to be multiplying with smaller values. It's just going to be easier to factor and reduce with smaller values because you're keeping, like, you're going to have the times table memorized, right? And you're going to have it memorized maybe up to 12. It's possible. I don't know. You can do it, right, if you want. But for the most part, people memorize up to 10. 10 times 10, right? So that's fine. So you should have all those memorized, so you'll be able to factor and reduce because you know the times table really well. Anything greater than, let's say, 13, you might have to work out and do a little extra math and figure it out, right? But if you keep your numbers small, you'll be able to factor and reduce quicker with smaller values, all right? Turn it up. Okay, so that's a tip. It looks like you can, and I wanted to test it. That's why I did that. You can actually reduce right at the beginning. And then I also recommend you reduce at this stage as well. Okay? Before you multiply. Because you're going to end up with a large number. Yeah, that's my point. Right? It's easier to reduce with smaller values. Okay? A mechanic mixes oil with gas to lubricate the cylinders in typically a 2-cycle motorcycle engine. He uses 1 part oil. I don't know. I'm just going to call it PT, whatever. We're just going to, it's not pint, but we're going to pretend, okay? 1 part oil. And 32 parts fuel. Okay, that's typically 2-stroke. Okay, what is the ratio of oil to gas? That's really easy, right? You just take these numbers here, guys. Okay, 1 to 32. That's simple. There's your ratio. Done. Don't overthink it. It's that easy. Okay, how many milliliters, whatever, of oil would a mechanic need if he had 40 milliliters of gas? Okay? Again, ratios don't have units, but you can still use it use ratio proportion without units, okay? This is the normal, fuel mixture. 1 to 32. 1 part oil, 1 part fuel. Okay? Let's say, for example, he had 40. Okay, maybe he went to the fuel station, he bought a little bit more gas than he wanted to. Oops. So now he wants to figure out how much oil does he need to add now, right? So setup is key, guys. Okay, just go 1 over 32. Okay, equals. One side equals left-hand side equals right-hand side. I'm going to start using this concept. Okay? So, and again, you have to remember, okay? So oil is top. Be consistent. You have to be. Oil is on top, fuel is on bottom. He bought 40 milliliters of gas. I don't know why I put, let's just call it, I don't know, gallons or something. It doesn't really matter. Like, who buys 40 milliliters of gas? Ridiculous. Anyways, I guess it could be a pouring mixture. I don't know. So this is the unknown. What do we want? We want to use, I don't know, oil. I don't know. Let's just call it, I don't know. We'll just use O, whatever, good enough. Okay? That's the unknown. So obviously it's going to be a little bit greater than 1. You got to think of this logically, logical brain. Okay, this is your normal ratio, but he has 40. So therefore it's going to be just a little bit higher than 1. We'll see what it turns out to. Excuse me, guys. Same concept, cross multiply. Okay? So we'll set it up right here. 32 times O equals 40 times 1. I don't need to write the 1. Anything times 1 is the same number. So we have to isolate O. We want O to be just a value of 1, right? So O equals, just going up here now, numerator is 40, denominator is 32. At this point I could actually factor, right? So we know 8 goes into 32 and we know 8 goes into 40. So basically 8 is going to be the meat off the bone. What times 8 gives us 40? That's 5. What times 8 gives us 32? That's 4. O therefore equals 5 quarters. Okay, so this is, I had to try to remember mixed and improper. Is that right? Mixed. Mixed fraction. Let's turn it in. Yeah, I think it's improper. Is improper the right word? I think this is an improper. Let's turn it into a mixed fraction, right? How do you do that? It's really easy. 4 goes into 5 how many times? Once, right? Without going over. So that's 1. 4 times 1 is 4. How do you figure out the numerator? It's simply because we've figured out 4 times 1 gives us 4, right? If we go 4 times 2, it's 8. 8 is greater than 5. That's too much. We got to be below 5 without going over. So there's our 1 right there. Okay? So we take the 4 and we go 5 subtract 4. Okay, 5 subtract 4 gives us 1. Our denominator never changes. Okay, that's how you do it. So that's 1 1/4. In case you needed to know that. So O ends up being 1.25. Because 1/4 is a quarter, right guys? Think of it like money. 25 cents. A quarter. Which is greater than 1. Looks good to me. Now, if you had some ridiculous number like 10,000, well, obviously you should know at that point that you've done something wrong, right? If you have a ridiculous number, you have to kind of think of your answer and go, okay, what's my answer logically going to be? You know, you kind of estimate it in your head. It's called using the old noggin. Okay? Not everybody could do it, but you guys can, because you guys are part of the 120 and higher IQ club, right? I don't know the percentage, how many people are in the world, but there's a small, minute percentage of people that actually can do this stuff, right? And are willing to. Okay. That takes care of that. Let's move forward. We're doing good, still on time, hopefully. Yes, we're doing great. Okay, what do we have? Ratio compares two numbers with the same units. Two equal ratios form a proportion. The proportion A over B equals C over D, which we've been doing, right? And they're showing the cross multiply, which I have done. State two ratios equivalent to 2/5. Well, it's pretty easy, right? I could just double these, right? We know if I multiply the numerator and the denominator by 2, I'm going to get 4/10, right? It's the same thing. If I go 1.5, I don't know, maybe I'll just use even numbers. So we're going to get times 3, let's say. We're going to end up with 6 over 15, right? There we go. They're all equivalent, guys. You can divide them all and you'll still get the same decimal value. What is if I double that, that's 4/10, 40%. Is that right? Should get 0.4 for every one of them. 2 divided by 5, 0.4. Yeah. I figured it out because of this, right? I know that's 40%. You just need to get that 10 denominator, or even it could be 100. It doesn't really matter. 40 over 100 is the same thing. All I did was multiply it by 10, top and bottom. All right. Reduce. So we've been practicing reducing already, guys. A lot. I think so. Right? Fractions are not that scary, guys. It's just a number. It's just a number over a line, which is over another number. That's a number. Is a number scary? Is a single number scary? Is a line scary? Is a single number scary? No, it's not. It's just a line. It's a number over top of a line over top of another number. Reduce the lowest terms. Just look at it like parts, okay? We need a do you mind, bro? Must be nice to have money to do commercials. Anyways, hang on, guys. Okay, there. Just gotta skip the commercial here. Okay, we need a common number, right? This again, memorize the times table. We know 2 goes into 2, and we know 2 goes into 12. Just break it into parts. Really, that's what you're doing. 2 times 1 is 2. What times 2 gives us 12? That's 6. So we're left with 1 over 6. That's as far as we can go. Nothing else more than we can do. If you divide it, you should get the same number. 15 over 25. Okay? Same concept, guys. 5 is going to be our common number, right? So 5 is going to be the meat off the bone. That's 3. And that's 5. 5's cancel. We're left with 3 over 5. Okay? Easy peasy, lemon squeezy. 8 over 12. Try to do some here quickly. Okay? So just to figure out a common number between the two. That's going to be 4, right? So equals 4, 2. All we're really doing is breaking this number into 2 numbers and breaking this number into 2 numbers. That's all we're doing. That's the common number, because the common number, we need to be able to get 1. We want 1. Same number divided by same number. That's the reason for factoring, guys and gals. And boom. There we go. Done. These problems, type of problems, you guys should it should only take you like 30 seconds to do. Okay? Or if you need a minute, take a minute. But be aware, you only have 2 minutes per question. If you do one question in a minute, that means you got 2 minutes, 3 minutes for another question. As an example, okay? You have to balance the time. All right, guys. So times tables memorized. We know 3 goes into 9 and 3 goes into 27. 3's our number. 3 again, that's our meat off the bone number. What times 3 gives us 27? That's 9. I could have went a little bit higher. I didn't take enough meat off the bone. As a matter of fact, I'm gonna backtrack now. You guys can see I could actually reduce this even more, because I know 3 goes into 9. So I didn't find the largest number, right? So 9 is the largest number. So that's 1, 9, 3, boom, boom, bye-bye, 1/3. Done. That's as far as you can go. Uh, 30 into 70. I've already showed you guys a quick way to do this. Boom, boom. But your teacher might want you to show your work. Me, I just cancel the zeros. Done. Because really, you're factoring 10 out of it, right? You'll still get the same number, right? 10, 10. You can show the work if you want, but essentially that's the same thing as canceling the zeros. Easy peasy lemon squeezy. One more. 12 over 30. Got lots to do, guys, gals, so that's why we're kind of pushing through them quickly. If you need, just stop, pause, work the problem. If you need to, that is fine, guys. Take whatever time you need. Okay, so 4 actually goes into 30. That's the biggest meat off the bone. Now, I know if you look at 30, you go, well, 4 doesn't look like it goes into it, right? But you got to think of it like this. Let's see if this will actually work. Am I right? No, I'm thinking of 60. That's what I'm thinking of. That's my issue. Yeah, 4 doesn't go into it. My bad, guys. Because I'm a little bit tired, but no, not making excuses, but it didn't take me long to figure it out. 4 does go into 60, though, because I have 2 15s here and 2 15s here, right? So I have 1, 2, 3, 4 15s, which gives us 60. So I am incorrect in saying that. That's fine. As long as you catch your mistakes, that's key. You don't want to continue a problem with errors right from the beginning. You want to kind of pay a little bit of attention, that's all. And I'm trying. So getting a little late. I was thinking of doing another video for you guys. Okay, 3. I'm going to use 3 because I know 3 goes into it nicely. Okay, and if I have to reduce again, then so be it. So let's just start with a number we know. So I'm going to use 3. And 3 times 4 is 12. Yeah, as a matter of fact, I could have used, just coming in, think of it, 3 times, I could have used 6. Yeah, I could have used 6. But that's okay. So how I figured that out, so this is 10, right? So far I'm using 3, right? But I know I could factor 2 out of both of these. So 3 times 2 is 6. So I could clean up my work, pull out my eraser, backtrack, and we're gonna pull 6 out of there instead. So that's 6 times 2. 6 times 5 is 30, right? There we go. That was a lot quicker. We found the largest number. That's what we want, guys. 2/5. Boom, boom, boom. All right, let's drop the yays. Why not? So that's reducing in a nutshell. We're going to be doing a lot more factoring and reducing anyways, guys, so you'll see more practice, don't worry. All right, solve for x. Okay, here we go. Ratio proportion. Solve for x. So what they've given here is, check this out. I'm actually going to start doing this, I think, because I think it works. So I'm going to save myself some time here. Instead of multiplying large numbers, again, it only works if it's in fraction form. You have to have a numerator over a denominator situation in order to be able to factor and reduce, okay? So I'm just going to cancel my zeros, and I'm left with 3/5. I know I could factor 10 out of this and 10 out of this. So I'm doing that so that I could just work with smaller values and I don't have to reduce. Okay, there we go. Now we can solve. X on the left side, left hand side equals right hand side. It is going to be 5x equals 3 times 10. I'm just going to write it out. 3 times 10. Okay, and then we're going to isolate x, meaning I want x to be 1. And so I'm going to go 3 times 10 all over 5. I could reduce right here, guys, a little bit more. which is going to equal 3. We're just working with this number and this number, okay? I'm pulling 5 out of it. What times 5 gives us 10? That's 2. Pulling the 5 out of there. Again, we want the denominator to be 1 most of the time. We can't get it to be 1 all of the time, but we're going to try. Skip commercial. So we're left with, this cancels, this cancels. We're left with 3 times 2 all over 1. Therefore, x equals 6. Boom. Now, do I have answers for this? Let's see. 4a. Look at me. Boom. That's the answer. That's nice. I like that. Something I never really did when I was in college. I never did this step here. I never thought of doing it before. I could see that you can. So much easier and quicker working with smaller numbers, guys. Make math easy. Don't make it difficult, because math is really easy. All right, 8 over 6 equals x over 9. Okay, we can reduce right here. Because why not, right? We're going to use 2. All I'm doing is reducing this fraction, okay? That's all I'm doing. We get 4, 2 times 4 over 2 times 3 equals, there's nothing changing here. I'm not touching this side right now, okay? I'm just reducing, which works out to 4 over 3. Okay, I'll write it out here so you can see it. 4 over 3 equals x over 9. Boom. X, so now make everything in line, cross multiply. 3x equals 4 times 9. Isolate x equals, I'm not multiplying yet because I know I could reduce, over 3, which equals, 4 is just going to hang out by itself for now. The meat off the bone number is 3 and 3. Okay. So the 3's here cancel. We're left with 4 times 3 all over 1. I'm just going to write it right here. X equals 12. Good enough. Okay, let me check. 4b, 12. That's what I get, guys. Boom. Working with small numbers, smaller numbers, man. Guys, gals. Like I said, you still have to factor and reduce. You have no choice. So, okay. It's weird. Okay, 56. I'm definitely reducing that over 64. equals n over 8. Okay, we can't do nothing here, right? Because we have a variable over a number. There's nothing we could do there. But we definitely could do something with this. Again, this is in fraction form. We can reduce. I just proved that we can actually do that. So now we're going to think a little bit. Times table. 8 I have in my head. So 56 divided by 8 is 7. And 64 divided by 8 is 8. There we go. I found the meat off the bone number is 8. So 8. What times 8 gives us 56? That's 7. This is our meat off the bone number. That's 8. Again, same thing. I haven't done anything on the right side. Right side's just hanging out. It's neighbor 2 if you want. Okay, this cancels. Boom, boom. We're left with 7 over 8 equals n over 8. We get 8n equals 7 times 8. I'm just going to go up here now. N. Just bringing it all the way up here, guys. N equals 7 times 8. I'm not multiplying again because I know I could factor. The 8's cancel, right? You guys know 8 divided by 8 is 1, right? Therefore, n is going to equal to 7. Right? Because 8 over 8 equals 1. Look how easy that was. Too easy. How long did it take me? You guys time me? They got it as E. I don't know why, but what?
You don't need more apps.
Okay, do you mind commercials? I need more money. That's what I need. I need more views and more money. That's what I need. It seems like you are fine for money. I'm not. Okay? So, until you show me the money, commercial, I'm not going to share you. I really can't. They're not giving me the answers for those? Whatever, it doesn't matter. Okay, 7. That's what I get, guys. You could do the long work if you want. It's up to you. You can confirm my answer. Get used to factoring, guys, right? I highly recommend it. Reducing and factoring. That's why they teach you that stuff in fractions. I swear to God. I'm not, like, I'm fine and everything. It's like, when fractions happens in math class, it's like everybody falls asleep. It's like, that's the part you don't want to fall asleep. For real, for real. Okay? N over 16 equals 5/4. Okay? There's nothing we could do here. Okay? We can't reduce and we can't do anything here. So all we could do is just cross multiply. Okay? So we have 4n equals 5 times 16. Isolate n. N equals 5 times 16. All divided by 4. This is the point where you want to factor. 5, 4, 4, 4, and 1. Cancel, cancel, equals 5 times 4, all over 1, n equals 20. Let's drop the yays. Didn't take me long, did it? Pretty quick. You might even be able to go on your phone after your exam. No, I'm just kidding. Don't do that. Your teacher might say something. I don't know. You might get your exam done early. Yeah, I don't have the answers for that, but looks good to me. Okay, what else do they have here? Solve for x. What? Weird. I don't know how they do this booklet. They're doing things weird. Okay. Oh, it's just more. It's just more. Let's see. 5. I'll give you guys a couple here. Okay. And then we're going to carry on. I'm going to give you a couple of problems you can work yourself. And I'll give you the answers. I think I've done enough examples. Okay. Okay. So this one here, x is equal to 28. And I'm gonna make sure I give you the right one here. I don't want to mess things up. Here's another one. So we'll just call this A. Here's B. 4 fifths equals 6 over x. X equals 7.5. Or let's see if we can work this backwards. 7. Ooh. Oh, I hate working it backwards. It's easier for me to work them the other way, mixed in proper fractions. Okay, but it's 7.5. All right. You have to turn it into, I think it's, what is it? Let's do 14. No, can't think right now. Trying to turn a mixed fraction into an improper fraction in my head. I don't feel like thinking right now. For me, it's easier to go, I think it could be 15 halves. I'm guessing. I think it is 15 halves. For me, this is easier going this from here to here. So 15 halves is what I have in my head. 7 would be the number. Yeah, that's right. 7 times 2, and there we go. That's what it is. It is 15 halves. So I can do it. Okay, that's what you should have for x equals 15 halves. Okay? And if you want to practice a couple of other ones, I'll give you a couple other ones. I won't have the answers though for you. That's the only problem. Just be consistent. And I mean, If you want me to do the problem, just time frame it in comments and we'll see how it goes. I'll see how I can answer it for you. Well, I guess I could answer it and then put it in comments for you, okay? I'm just not going to work it right now, but I can work it later if you need me to. Okay, 3/5 equals 15 over x. Okay, 18 over 27 equals 36 over x. And we have 3/5 equals 15 over x. Okay? Boom, boom, boom. All right. Nancy owns a 2-stroke grass mower. The fuel for the engine mix is a mixture of blah, 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 1 to 32. It's kind of the same one that we did before, guys. The oil fuel ratio, right? How many liters of oil should Nancy mix with 8 liters of gas? If you've done my watched my what's that other series I did a lot of converting liters to gallons, a lot of metric. Hold up, I'll see if I can think of the not geometry. What section was that? Measures of area, I think. Check it out, Unit 3 series. And then there's mass, capacity, and temperature. It could be that, maybe. Mass, capacity, maybe Unit 3 or Unit 4. And I do a lot of converting metric to imperial and imperial to metric conversions, okay? And I give you a lot of tips, tricks, examples, and if you're used to an imperial system, I give you tips and ways to remember how to convert kind of quickly to metric, right? Anyways, so I'll leave you with this one. So hers is 8 liters of fuel, okay? Remember, you have to be consistent, okay? How much oil, right? How much oil? Okay, there's your ratio right there. You guys should be able to solve that. Right? I believe in you. You guys are 120 IQ club, okay? What is it? 0.05 percentile of the world that can do mathematics? Just jokes. But you guys are still awesome. You guys are awesome. How are we doing for time? That's it. That is it. I'll do one more quickly here. For an art project, Jan needs to mix paint. The ratio of paint, red paint to yellow paint. Red to yellow. So red, yellow. Okay, this is the ratio. I could write it in fraction form, I guess, here, but it's 2/3, okay? The ratio of yellow paint to white paint. What are they doing here? Okay, the ratio of yellow paint to white paint. I'm not sure what they're doing here. Well, let's just write it down. To white. They're giving us 3/1. 3-1. How much yellow paint does she need if she uses 500 milliliters of white paint? Okay. So this would be part A. Just giving you some word problems, right? Word problems help you think. Okay, so yellow paint. So I'm just going to go yellow. You have the ratios right here. Okay. And she has 500 milliliters of white. Okay. And then part B. How much red paint? So I'm going to go question mark and red question mark. Does she need, if she uses 750 milliliters of yellow paint? Okay. So to me it looks like you use this one for this one and this one for this one. That's what it looks like to me. Okay, guys and gals? Alright, awesome sauce. I appreciate y'all. Thank you for watching. You guys are beautiful, intelligent people. I'm telling you you are. Yeah, it's super epic that you're watching. It really truly is. I will see you guys in the next video. What are we going to work on next? That's pretty much it for that. I think we have answers for that, but let me know in comments if you like the answers. I believe that you can get it. We're going to work on rates. Okay? We're still kind of using ratio proportion. So, but yeah, work with some money, working with money, and yeah, stay tuned, check it out. See you guys in the next video. Thank you for watching. Johnny Whiskey Sharp appreciates y'all. For now, I am saying peace.